Hello everyone, this is Gopal from Engineering Physics third year. Today I would be giving presentation on finding parity of a number using Intel 8085 microprocessor kit using assembly language. So first of all, what is a parity, even or odd parity? Its example, uh, how to check parity, an assembly language program to find parity of a given number. So even odd parity, computers can sometimes make error when they transmit data. What is even or odd parity? Even or an oblique odd parity is basic method for detecting if an odd number of bits has been switched by accident. Odd parity, the number of one bit must add up to an odd number. Even parity, the number of first bit must add up to an even number. The computer knows which parity is using. If it uses an even parity, if the number of the one parity add up to an odd number, then it knows that there was an error. If it uses an odd number, if the number of one bit adds up to an even number, then it knows there was an error. However, if an even number of one bit is flipped, the parity will still be the same, but the error occurs. The even parity can't this detect error. It is useful when an odd number of 1 bits is flipped. Suppose we have a 7-bit parity, 7-bit binary word, 7 digits. If you need to change the parity, you need to add 1 bit parity to the binary word, then the parity of the word would be changed. Now we have 8-digit word. However, the computer knows that we have added 1 bit. Its parity bit, it is a parity bit, then therefore it was ignored and its parity has been changed. So suppose you receive a binary bit word 0101 and you know that you are using an odd parity. So is the binary word error? That means if the answer is yes, there are two bits, two 1 bits, as we can see, 01 and 01, which is an even number, and we are using odd parity, so there must be an error. Assume that we are using even parity with 7 bits ASCII. The letter V in 7-bit ASCII is encoded as 0110 However, their letter V will be transmitted because there are 4 ones in binary number of V. This is an even number. Parity is said to be 0. This would be transmitted as 011010. The 0 is added in the last binary and the binary number. If you are using an odd parity, the letter would be transmitted as 01101011. The 1 has been added in the last divine and the binary number. So this is assembly language program to find the parity of given number. I would be explaining this code in the assembler while I would be running this code in few minutes. Like we are like we if we give input of 52, decimal number 52, if we convert decimal 52 number to binary, it would be 100100, and it has odd number of ones. As we can see, we have 3 ones in this binary number, so it must have odd parity, so it would be output us as 0. So now we would be running the code. So this is the code which was written earlier in this slide. So XRA space A is here to clear the register's values, like assembler's value, so that we can work with the assembler. MVIB comma 033H is here to load in register B the number whose parity to be checked, and MVIC comma 00H is also here to initialize the register C, and add B is here to perform an operation so that the flags are affected. JPO 200H AH, it means we use JPO to jump if parity is odd to the address 200A in our memory location. INRC is here used to increment C if parity is even. Move A comma C, move the content of C in accumulators. STA 2050H, that means we are storing the result in address of memory location 2050H, and in the end we are using halt to stop the program. Now I would running the code. So first of all, we would be assembling this code, and now we will execute this code. So I have executed this code. Now it has been loaded on 000 memory location. As we can see in this here, the data has been updated in our memory location. Now as we stored our result in 2050H location, so now I would be checking our results by using this function. As we can see, the data in the 2050 location has been 1. That means our given number has been odd parity. If we change this to 2, like this is a hexadecimal decimal number, then and now if we execute this code, then it would be running like. So this is again a odd parity, even parity. The results are stored in 2050H. Thank you. This is all from my side.